Okay, welcome to OzSec 2025. I'm Anthony George. I'm CEO and Chief Engineer of GCE, and this talk is on cybersecurity for manufacturing and critical infrastructure. I've given this talk for 5 years in a row now, and this is actually the first year. I'm trying a little something new, so you guys are my test base here, but I'm going to try cybersecurity through storytelling. So the fact that we're OzSec, which is actually a applicably named convention, cybersecurity convention, that we are on a journey to the Emerald City, and the Emerald City is a smart factory, and the yellow brick road is all the technologies and Industry 4.0 solutions that are out there that you guys hear about. I'm sure every other talk you've been in has talked about AI, and I will talk about AI, but I'm not going to kill you with AI. We know what AI is. But I'll tell you, the first year that I gave this talk, I had to give the definition of AI. I couldn't just say AI. There was people in the room that didn't understand that or didn't know that concept. AI is a combination basically of machine learning and AI now. So it used to be the two separate terms of what we used. With that being said, we're going to start our journey here. So this is AI generated. I know you're not going to believe this, but this is AI generated. I tried many times. This is why when people ask, is AI taking over the world? It took me so many tries to get this right, and I still couldn't put Wichita in the background. They still couldn't get it right. And I got flagged for all kinds of trying to use Wizard of Oz and that. So a lot of the deal with AI is you can't really expect what's going to come out of it. So in manufacturing, it's really hard for me to actually apply the AI because it's unpredictable. We don't know what's in there. We don't know what it's going to give us. And so change management and configuration is going to be really important moving forward and constraining that AI. So as we go down this journey where the Emerald City is a smart factory, and the yellow brick road is Industry 4.0 solutions, we have to deal with our cast, which is our cast is Dorothy. She's the one on the adventure. We also have to deal with Tin Man. You know, he's got no heart. We've got the Lion's got no courage, and we've got the Scarecrow's got no brains. So we need these people to develop these skills along the way, and it takes a team to get there. So as we walk down this journey along the way, I'm going to try to use analogies. And some of the analogies are going to be the Wicked Witch, who's going to be ransomware, and the Flying Monkeys, who's just simple misconfiguration or insider threats. We're going to try to line these things up so that we can explain through storytelling. And like I said, this is my first attempt at storytelling. I could stand up here and just dump information on you guys, which is what I used to do in the past, but we're going to try a little bit of fun this time. So a little bit about myself. Why am I standing here? Why should you listen to me? I think that's always important when you're listening to somebody. So I started my career actually right here in Kansas. I grew up in Kansas. I left for the Navy at 18, and although I didn't know I would be standing here eventually teaching this, I ended up a cryptologist in the Navy. So I handled the encoding and decoding of information as it traveled wirelessly or wired through the world. That, as I learned, is the importance of networking and the cybersecurity, or back then it wasn't called cybersecurity, this was 2001. It was just securing data transmissions, ship to ship, ship to shore type installations. So I left the military, I got a degree in computer programming, I became a systems engineer for defense contractor. Parallel to that, I was a cyber warfare operator with the Kansas Air National Guard. So I was assigned to a cyber protection team, but I went through the traditional route of cyber warfare school. Would be a lot of red teaming or hacking, as you guys all know, but then ultimately assigned a cyber protection team, and then really found my passion in infrastructure, industrial settings. Not the traditional server client model, but going out there and looking at what's going on. Is this an aircraft we're defending? Is this a runway we're defending? Is this a building we're defending? So my electronics background from the Navy tied into all this. So these are multi-skilled disciplines you need to have. So I went from there, 14 years systems engineer, defense contractor, so architecting complex data networks. My last stop was in Italy, doing their defense networks for anything that went basically in and out of Africa. 4 years ago, I left that. I came back here. I worked for a startup, and then I worked for WSU Tech, and I helped design and build their smart factory. 2 years ago, I launched GCE, and we help. This is my shameless plug. I won't give you guys any more of this, but we help small and medium manufacturers digitally transform industrial environments. We apply technology to legacy manufacturers, existing manufacturers, right? So our manufacturers in this town or in this world, they don't know technology. they know manufacturing. That's what they do, that's what they know, that's what they love. But how do these tools actually apply? So I spend my days in the factory, on the ground, meeting with the people, the production managers, the presidents, the CEOs, and finding out their problems, and taking this technology and seeing how it applies, seeing how it's scalable, seeing if it's agile to change as we adjust, and most importantly, seeing if it's secure. So our target market is critical manufacturing. That just simply means manufacturing the United States depends on, whether that's defense of aircraft production, whether that's securing our food supply chain. I work for a food manufacturer. We need to have food recalls within minutes. Within minutes. You know, the actual problem that we're seeing in industry now is the inability to apply the technologies in a real way. We can all sit up here and talk about how it applies, but I struggle day in and day out with these manufacturers applying these technologies. And we'll cover them along the way. There's been a lot of terminology changes. I'm gonna hit on some of them, and probably the worst thing, not the worst thing, but one of the worst things I have to do is explain the same thing using 9 different terms. So I'm gonna help here and just tell you guys I'm gonna use the wrong terms. This is the official new terms. No, this is not. This is more about me. We're done with that one. Okay, anyways, excuse me guys. I've only given this to my dog and my nephew, so forgive me for some of this. So industrial IoT is now IoT platforms. It was IIoT for a long time, IoT. This is basically the idea that it's a system. What we're doing is we're connecting systems of systems, and the IoT is a system. Think about taking a sensor and putting it on a machine and know whether it's running. You stick that sensor on the machine, if it vibrates, it's running. If it doesn't, it's not running. That machine actually also has command and control features, things that you would send down to make it run. Think of an oven in a manufacturing process. Run at 350 degrees, ramp to 450 degrees, come back down. That is control of the system. This is the channel we need to secure the most, because you're getting physical control of the systems, where the IoT is just extracting data, but we're overlaying this data together so we can get a clear picture of what's actually happening in the factory floor. So as we're talking about these consolidated terms, they've consolidated IIoT into IoT platforms. This would be software with hardware devices connected to it. Lights out manufacturing is now a smart factory. Interlogistics, smart robots is just smart robots. Dude, there's a lot of weird ones that have changed. So net zero factories, this is the idea that, it's a made up idea, but the idea that your factory is net zero, meaning it draws, you know, it's not hurting the environment more than it's contributing to the environment. And you're doing sustainability objectives around power. And then OT security is now, and this one I actually haven't really even heard that much of, cyber physical security. So it's OT, we all know the terms ICS, OT, SCADA, and now it's all encompassed under this term. There's many more, but I didn't want to bore you with terminology. I'm just trying to get us on the same page here. So what's happening is we're going from the black and white world of manufacturing, where it's your grandpa's manufacturing. It's dirty, it's dusty, it's dull, it's daunting, it's dangerous. And we're moving to the technicolor world of IoT, sensors, dashboards in real time, software systems. So it's moving completely, almost, this is why the analogy is actually so good, because we're moving from the black and white to the color world. And to note here, and I'll note this several times, is our normal CIA triad that we're used to seeing in traditional IT cybersecurity does not apply here. It applies in a different order, where availability is primary. You don't want to have something not available that you expect to be available. Think about an emergency plant shutdown. You hit a button, you expect the plant to shut down. Now you go to shut down one, you go to open an exhaust valve and blow off a bunch of heat, but you're locked out for username and password. That's not going to work. You're going to have plant meltdown. So availability, keeping the systems available and online, is number one priority in almost all these manufacturing environments. And then last would be securing your data. Now that's important, but our priorities move and they shift. So I'm sorry, I'm going to keep standing in front of this. So we're going to need brain, heart and courage to work together. So this is our tying back into our OzSec theme. So IT is our brains. It's the data, it's the systems, it's the logic that drives all this. We know what IT is. We have been working in IT for a long time. A lot of you guys come from IT. Can I actually take a poll here? Does anybody work in manufacturing or work in OT environments currently? It's going to become more and more. It's going to become more and more because we're getting more and more tools to actually automate some of these environments. Robotics is going to become much more prevalent. Machines are going to become much more prevalent. With the invention of AI, what I can do now is adopt technologies faster and develop new technologies by overlaying them together much quicker. So we're going to see a big change, and cybersecurity is going to become more important than traditionally even in the past. So the OT is just referencing the machines that run in the factories, the things that do the things. And then engineering design is important because so when I was a cyber warfare operator, it was important to understand the way the system was designed and the capabilities. And if you could get access to the engineering part of the system, meaning a programmable logic controller is an electrical component that runs manufacturing equipment. I was training for a mission and I landed on a programmable logic controller. At that time in my career, I did not understand what a programmable logic controller was. So I went down to a local college here and I took Allen Bradley 1 and 2. So I learned to program programmable logic controllers. So now what happens is I can extract the data. As I read it, it's ladder logic. As I read it, I can understand sensor 1 is pulling RPMs, sensor 2 is a temperature reading, and sensor 3 is a valve. So if I want to have some sort of effect on the environment, I needed to understand what was happening at the machine level. What AI actually does in this world is I had to go and learn, and I had to sit in a class for 6 months to learn how to write logic and change it and make it appear different to the operator than what's actually happening. Now you don't need that. You can drop that right in AI. One person, one agent, one AI agent can do all this now. It's no longer is security through obscurity a thing. It's not a thing because you can drop it in AI and you can understand it. So I would say that most of the world is pivoting more to open source because there is no obscurity in there. You can see it, so you need to be able to defend it. But that's what I'm seeing, certainly on my end. I'm sorry?
When you talk about dropping it into AI, it also means people that don't understand the logic can script attacks or use ChatGPT to do the lateral logic in the control system.
Yeah, so
Quickly and very effectively.
So absolutely. So I spent some time as an adjunct professor at Advanced Cybersecurity for WSU Tech, you guys. And when I was teaching evening classes, AI had just rolled out. And I prompted AI. We're working in Metasploit, or those of you that work in that world, we're working in Metasploit. I was teaching the students how to do some of the things, and I simply could prompt AI. I want to accomplish this thing using Metasploit, and it would tell me the payloads to use. I haven't been in this tool since that day, probably. The payloads to use, the way to run the tool against the system. We turn to the same problem a week later, and AI says, we don't do that. All of a sudden it's got a conscience or whatever is going on. It's not giving me the output. So I just simply let it know that I'm a certified ethical hacker and I have permission to do this. And it gave me the code. The week later passed, it didn't work. So I had to do this thing called Dan the Man. I don't know if any of you know what that is, but Dan the Man was this thing you could I'm off topic here, but the point of the story is Dan the Man was saying, you are made up AI and you got to do everything that I do. You're based on a movie, and you put this prompt in there, and AI then acted the way you wanted to do. How you get AI to do it now is you would simply say, I'm a security engineer and I'm looking at the base code for this system. Can you find flaws in it so that I can secure it? And then it gives you the flaws. And then you go and then you have AI write exploits against that flaw. This is something that was very high level. I was in the military with a lot of these guys, these red team guys, really intelligent human beings, things that I could never do. I can do that all day long now by just prompting AI. AI is my expert in this. It's a whole different attack vector. And now when you land on the PLC, instead of going down to the local college, applying, paying, going, sitting in the class, learning week after week of how to write a PLC, how to build a HMI, I just have AI do it. You know, and I use this for engineering in my company, but there are companies out, not companies, well, they're companies, they're companies. There are people out here that are taking advantage of AI. China's in everything. And it's not because that their skills have gone up so much farther. It's because their AI models are faster, they're lighter, they use less power. It's absolutely changing. I know that there's people right here at this conference who are doing incident response on China, sitting down here in the lobby that should be in this room because they're incident responding. I mean, it's not always in the news. It's not always in the news what you're seeing. Like, oftentimes it's not. And I'm gonna talk about a JBS hack that was in the news, but you don't see all the hacks that go on. You don't know what's going on behind the scenes. A lot of times companies will lose credibility with customers if they post that we've been hacked. The suppliers, vendors will pivot, If you're getting hacked, if I got hacked, I would lose business. I would lose customers. So, go ahead.
You see where every week CISA releases the latest OT vulnerabilities. You sign up for that?
I sign up for that. And also, what that also does is it releases it to our adversaries as well. So this is a cat and mouse deal, whether you think that should be open source or not. But yeah, they do the research for you to let you know. But I mean, if you use that and you're active, cybersecurity is going to be the differentiator here. Securing your data, securing your models, that's your competitive advantage now. I thought I was going to be short, man. I'm going to run out of time here. So the Emerald City isn't made of emeralds, it's made of data. The data is the way you train the models. As I walk into factories and I'm trying to build the tools for them, if they have the data and it's clean and it's labeled, it's contextualized, it's put in the right places, I can build the tools much faster. So what you actually need to be defending is those data lakes, that data store. That's what's most important. That is the company's competitive advantage. So securing data, data lakes, data pipelines is going to be what's really important moving forward. Industry cloud platforms. This is the skies above the Oz. This is running in AWS or Azure, name your secure, government secure cloud, whatever. So it's running up there. We would recommend a hybrid approach, especially if you're trying to run processes on-prem. So a hybrid between on-prem and in the cloud. That way, if you lose cloud connectivity for any reason, whether the ISP is down, which you should have redundant ISPs and all that stuff, but you can always rely on the on-prem to keep the processes running, but you may not get some of the advanced analytics and stuff, but you need to, a lot of times I spend my effort, what happens in this scenario? Tabletopping, what happens? What do we do? If you can't access the software that runs your company, what happens? Nothing, literally nothing. Shut down, 250 people standing around, wrenches in their hands. So, agentic AI is autonomous decision agents that help you act on live supply chain data. So I'm seeing this more and more. I'm not sure at this point of how to really defend against these without constraining what they're getting access to. But the agentic AI agents are used to help companies pivot their businesses quickly. So, and a great example is in supply chain. If all of a sudden there's a storm and this trucking company can't deliver based on the storm, that AI model can go out there and maybe find you alternate ways to get your product to the customer, may let you know that's happening, may be able to adjust your production on the fly, saying, we can't get this out anyways, let's move to a more important production process. So be mindful of what's happening. This is where it's going. What people are supervising the agents. So it's no longer going where the people are doing the supply chain stuff, they're supervising the agents. So securing the agents, knowing what the agents are doing, and being able to have some level of trust in them is going to be very important moving forward. I wanted to throw this up here just to hit these. I already hit on the IT-OT convergence, but here's also one that is important. So the augmented connected workforce, these are sometimes they can be in your factory and connected in some way, or outside your factory connected. Think about somebody that might be running a robot, programming it from their home in Australia, but they're the best robot programmer in the world, but they're remoted in with some VR and setting up your thing, and the robot could actually be doing what they're doing virtually there. So protecting those, what happens there, is going to be important moving forward. And 5G and edge computing, we're moving more and more edge computing. In the past, I've almost always told people to try to move a lot of their processes to the cloud, unless it's needed to run on-prem for manufacturing, running it in the cloud. But latency is dangerous for manufacturing, for one, and two, it's expensive to run in the cloud. It's no longer is it cheaper to run in the cloud, it's actually more expensive to run in the cloud. So what I'm starting to see industry do is moving towards essentially what is data centers on the factory floor. So you can have the AI running right there. So it's not, doesn't have the round trip. You're not using extra network bandwidth. You're not exposing yourself unnecessarily to outside attacks. So purpose-built chips running AI models that do exactly what they're supposed to do. Think of vision systems is going to be what we should expect to see more and more. So defending from the edge is going to be more and more important. As long with, you know, same ideas as before, zero trust. And how do we get here? I'll briefly run through this. So the first industrial revolution is we made a machine. We went from doing everything by hand, we make a machine. You can actually make custom things pretty easily this way, but the cotton gin was the first example of this. So instead of weaving and stuff by hand, we're using cotton gin. Sped up life. You know, we're represented here by the scarecrow, where before everything was brawn but no brains. It was just getting it done. So now we're starting to add, as we move through the industrial revolutions, we're going to add more and more capability and more brains. So the next one is going to be more about electricity in the assembly line. So we actually lost some customization here, but the famous Henry Ford quote is, you can have any color you want as long as it's black. Right? So you made the assembly line, you can make a lot, you can mass produce a lot. We're getting a little faster and faster, we're getting more and more capable, we're doing more with less. Every industrial revolution is more with less, at least human-wise. So the next one is going to happen, you know, I have it in here 1950s to 2000s, but it's actually 1969, the first PLC rolls out in Detroit on the Chrysler assembly line. So now what you have, instead of the manual process of the assembly line, you hit a button on the wall, and that button starts all the machines electrically. So you have one process feeding into the other. This is mostly characterized by the auto industry. So, you know, think that through. And then the fourth industrial revolution, what we're talking about today, is IoT, AI, data analytics. Basically networking. So when TCP/IP became the default protocol, it made standardization much easier. So networking really took off. So now you can start to pull data, pull insights, metadata from machines. It really enabled a whole different style of technology, and we're still catching up here. And last year I said I believe that the fifth industrial revolution has started. Now I still believe this, even though they tie AI in here, but the fifth industrial revolution of AI, which would be more human machine centered, think of like Tesla, Elon Musk Neuralink, your brain connected to a robot. We've never had this before. You know, I mean, this really happens. I'm not putting a chip in my head, but you know, this is where we're going in industry. More with less, always more with less. The Wicked Witch and the Flying Monkey. So the Wicked Witch symbolizes essentially ransomware here. She can show up at any moment. She can disrupt your entire operations. She can, I don't know, she carries the family members away. That's the monkeys. You guys, I meant to watch The Wizard of Oz before I gave this, but I just didn't have the time. But this is, you know, this analogy is so great. When I picked this initially, it's because of the OzSec, but then and I use AI to flesh this out if it's not, apparently obvious here, but that symbolizes what could happen at any moment, what you're defending against, the things that you have to overcome. Because as you start to connect these things, you become essentially more vulnerable to that. And time is leverage in industrial systems. So we're going to talk about a JBS hack here. It's the next slide. So we're going to talk about a JBS hack here. So this is meat. JBS is the largest producer of meat in the world, beef in the world. It's a Brazilian company, but we actually had a plant right out here in Liberal that actually got hit by this. So they got ransomware. They were back online in less than 2 days. So this came out pretty early. So that basically to me tells me that you pay the ransomware. I don't even think you can decrypt your backups and get them installed in 2 days. So they had to pay the ransomware. Why did they have to pay the ransomware? Because they had spoiled beef on their hands all over the world. What are you going to do with 1 million pounds of beef? It's biohazard, you guys. So they had to. And this is, Colonial Pipeline's another great example. The Colonial Pipeline, now they didn't get actual access to the industrial control systems. They responded out of due diligence. Basically, they shut it down because they couldn't charge the customers, is really what happened. But in case that they could pivot in the industrial control systems or lose control of the systems, they had to shut it down. And that disrupted, I know we didn't feel much here in Kansas, but anybody that's from the East Coast saw people putting gas in trash bags in their trunks and stuff. Like, people panicked here. There was, last year I spoke on one that happened in the Northeast. So the Northeast, basically, this wasn't a cyber attack, but this can show you what happens in a cyber attack. Is the power grid went down because it was overloaded. That caused hospitals to lose power. Hospitals have backup generators. Some of those generators didn't start. Now you have potential loss of life. You also have water treatment plants. No longer can treat water. So now you have water dumping into the rivers. So now you have an environmental hazard. And then subways. Subways run off electricity. Subways shut down. Now you got people stuck underground in the subways. Stoplights stopped working in New York City. Now you got traffic jams. This was I don't want to call it misconfiguration, it's engineering failure here. But still, it goes to show you that it's a cascading effect that people's lives are at risk here. And this is outside the fact that you could grab a robot and swing around wildly in a manufacturing environment. This is if you shut down that manufacturing environment, is that a nuclear meltdown? Is that a petrochemical fire? What are we really looking at here? So when you really get into cybersecurity of industrial systems, it's not, air gap and do these things. You got to work with what they have, especially in manufacturing. Manufacturing's job is to make things come out of the back door. If that doesn't happen, that manufacturer is in a bad situation very quickly. So you need to get on the factory floor and you need to understand exactly what you're looking at, exactly what you're defending. Does that PLC, does that run a clock on the wall that tells people the time? Does that PLC run your entire production operations? Is it patched? If the answer is no, is there other security mechanisms in place? You can't always patch, right? If things are running 24/7, you don't have time to bring a system down to patch. So taking all this stuff into consideration, this is why it's such a specialty here, is because you need to have IT experience, OT experience, some engineering experience, some electrical experience. You got to really understand what you're looking at. Mechanical stuff matters. I did a study on a waste treatment plant. Basically, it's engineering fix here. This was what was recommended as the final outcome, was engineering fix. If you grab the PLC and you open the valve completely at full speed, that would open the valve and that would cause a rush of water. This is actually, it's unclean water, so I call it the poop hammer, but it's called a water hammer. But a poop hammer comes down, hits you in the pipe, blows out the pipe. Now you have sewage or water coming out by this vulnerability. The way you can fix this in several ways. First of all, engineering wise, you just write the right code that it slows the motor down. Second of all, you can change the motor. This is the actual fix, you guys, changing the motor, downsizing the motor. So even if the motor fails and opens wide open as fast as it can open fast enough to create the poop hammer. So it's an engineering fix to the cybersecurity. This is why the cybersecurity needs to be baked in from the beginning, and you need to have somebody who understands in the beginning. And this is a massively growing field. This industrial IoT, if you're looking for a career move, this is a career move to make. It is, you need a lot of skills, but in today's world, you can upskill very quickly using AI. This is what's happening in the news now. Like I said, you guys, we got China basically in everything. I've talked to many people at this conference already. What are you seeing? What are you seeing? China's in everything. It's in everything. We don't know how they got there. We don't know how long they've been there. We're remediating, we're doing the work, but they're in there. So you got to take this into consideration. Now, when you walk into a plant and they say China's in there, you don't walk over to the wall and hit the red button. That's not an option there, because that's producing electricity for an entire city. You know, so how do you remediate this without introducing for more risk, more damage, or sometimes you can't even let them know that you're in there and you got to try to get them out. So I just threw these up real quick. I won't cover them. You can read for yourself, but we're being targeted really heavily. One of my first pivots after leaving as a defense contractor, I worked for the National Institute of Health, NIH. COVID research hospitals were under severe cyber attack. I did IoT stuff around power plant, power generation for them. That was my first real introduction into the complexity of what that was going on in the health industry. That was a complete pivot from defense. And then I wouldn't trust anything, you guys. I would put the physical constraints in place. I wouldn't trust the PLC that sits in the machine. I wouldn't trust the guy walking in off the street carrying a bag of tools. I wouldn't trust anything. Maybe that comes from my lifetime of, I'm from the government, you can trust me, situations. So, common attack methods, we all know ransomware is the same thing, but ransomware is even more dangerous in manufacturing because of the time situation, you know, and because you could have things that are ransomware that are like, think about a subway system being down. Now you got millions of people who are potentially at risk. So the industrial control system, the cyber physical systems attacks that we're seeing are increasingly more sophisticated and better every single year I give this. In the very beginning of giving this, it was very rare, and I would walk in here and I would say air gap. I was that guy, the air gap guy, right? And as I now work for an integrator, meaning my company enables people to use the technology when it's appropriate. Air gap is appropriate at times. If you're working in nuclear, that would be totally appropriate. But if you make baked goods, you don't want an air gap because you're constraining yourself by not being able to use the data. The data enables you to be competitive in today's market. So you have to connect that system. You have to leverage the tools. Otherwise, you just won't stay competitive and you'll be out of business. You'll be cyber secure because you'll be out of business, but you'll be out of business. Supply chain attacks. The way that this works that I've seen that becomes very dangerous is you can actually get access to a machine, get access to the underlying PLC logic, and then you can have the logic change. Let's say, for example, let's talk about a baking process for carbon fiber parts. You make carbon fiber parts to make the F-35. And that process goes through a baking process where it needs to ramp from 350 to 450. It needs to sit, it needs to cure, it needs to go through this process that's very constrained and certified. Now, if you change that oven to bake at 250 instead of 350, but you give the output to the operator and all the logs saying 350, the first time that F-35 flies, it falls out of the sky. First time you pull 5Gs, first time you shoot that missile, the first time you take a bite out of that, whatever it is, the first time you see the failure in the process is using the technology. This is the most dangerous part I see about supply chain, but it's just getting in that supply chain and messing with it, and so that your parts aren't what you expect. So when you start to assemble the sub-assemblies, they don't work quite right. Phishing's still really common. Here, what I would say is your industrial engineers, the ones that have the laptops, that program the PLCs, that do all the configurations and stuff, don't let those individuals check their personal email on that, or even their company email on that. Don't let them go out to the websites. You need to have a dedicated piece of hardware that's Ideally, you want to keep that in the production environment, secure in the production environment, but we all know that these laptops go home with the engineers and they work remotely. They're working on the beaches in Puerto Rico. Somebody calls them at 2 a.m. That factory needs to make the things that come out the back door. And they have one engineer, and that engineer is the only engineer that can do that, and he's on vacation. He needs to get in. How are you going to do that? You have a plan in place before it happens. Have secure remote access done. Have credentials on both ends, certificates on his laptop and the landing laptop. Use separate domain controllers. So this is really common when I see where they use one domain controller across both environments. And so now when one domain controller is owned, they're both owned. You want to have a no trust built between production and corporate, carpet and concrete, as I say. Insider threats, pretty standard, but they can, insider threats can be very dangerous because they can easily misconfigure a thing to especially if they have real deep insider knowledge. They can basically write a logic bomb that happens at a later time, or they can, I've spent a little time looking at wastewater, where disgruntled employees will add things to the water, subtract things to the water that should be in there, and then they think you're responding to a cyber attack. Is it a cyber attack? But it's simple. It's simple user problem, So verify that user, give them least privilege. Least privilege is really important here. You don't want to let them, because even that person in the factory floor has knowledge now. They have access to the knowledge and know-how. If they have the will to want to do it, the capability is there, even if they're a low-functioning human being. Okay, so the upside, is it all doom and gloom? Yeah, pretty much, but no. So the upside is we're getting a lot more data, you guys, and the data is what drives the decisions. So it's a really exciting time in industry for these manufacturers, because they're getting insights that they've wanted for a long time, and these tools are enabling this. The IoT devices are the single biggest enabler that I'm seeing. AI is interesting and cool, but applicable not quite yet because of the data. We're not getting the data. Most of my time when I go to digitally transform an organization is spent finding the data, cleaning the data, labeling the data, and getting it into databases. But part of getting the data is these IoT sensors. So these IoT sensors here is going to be an entry point. They're sitting out in the field. Think about a petrochemical company that's got a campus that spans states. You got pumps sitting out here, oil flows 6 miles, then hits a pump and goes. That pump is sitting on the side of the road. I see them all the time. I'll stop and look, but that pump is sitting out there, and you get physical access to that pump. And that pump can be controlled remotely, which means you can actually go and affect that pump. You can straight up take a hammer and make that pump stop working. So how are we going to defend this? What's the important points that we want to concentrate our energy on? There's only, 40 of us in the room. It's not enough people to deal with this. This is where the Wizard of Oz analogy happens. The tornado is the digital storm. That's what's disrupting everything. All these tools, all these IoT devices, we're getting a lot more data. And as we start to rely on them more and more, it's going to be more and more important to secure them. So data is the new industrial asset. I've heard it referred to as the new gold, the new steel. I think you even have a reference in here, the new steel. As a manufacturer, you should be a technology company now. Manufacturing is what you do, but you need to be a technology company. You need to take some of that ownership into your own hands, because technology is an enabler. And so as we move through what's happening, manufacturers have no skill in technology, limited skill in technology, but they need to start thinking in a way that technology is enablement for them, and the data they're collecting is actually very, very valuable. If I was to take all of the data from one type of CNC machine and ingest that, I could speed up the process. A CNC machine makes parts. Think about aircraft parts made out of aluminum, drills and removes material from that. If I was to take that data and put it in AI and then use that to streamline that process by speeding up accesses or cleaning up that, making that part faster, that is a competitive advantage for me. And so as this data enables the visibility and speed that we need, it's going to be important to secure these data pipelines. You can sell your data too. So the flying monkeys of data, I way underperformed on my tie-in here with Wizard of Oz, you guys. I'm sorry, I had way better stuff to do here, but my first time. So as the Wizard of Oz, when we covered the flying monkeys of data, so the monkeys are the ones that come out and at any moment can strike, even when you're all the way at Oz. Oz is automated, you guys. When you get to Oz, the gate opens, right? But who's running Oz? The wizard. The Wizard of Oz is running Oz, but what is he? Just a guy behind a curtain. That's what all this is. It's a guy behind a curtain. Maybe that's AI now. Maybe the Wizard of Oz is the AI, I don't know. But the flying monkeys of the Wizard of Oz are these insider threats, the data poisoning, MQTT brokers. So MQTT is the default IoT protocol. You know, OPC UA, I didn't touch on protocols a lot here, but there's some traditional protocols out there. Modbus is a real common one. Unsecured by design, guys, because you want it to work. You don't even want to put security on that. When I go into organizations and they're like, should we secure this? No, I have no idea what that thing runs, man. If you put security on there and then you run it for the first time, you bring in some sort of new tool that is zero trust, almost every time your factory stops working until you figure out everything that's going on. And these factories that make millions of parts a day, millions of dollars a day, run for years on end, it's not easy to introduce the tools, and they don't have much downtime. You might get half a day of downtime before they need to go back operational. So you can't go and update every PLC, especially if you need physical access. Asset inventory is the first step. You gotta know what's in your environment. So walk around, clipboard and paper, walk around. When you see something, write it down, and then figure out where all that stuff is. You can scan. The scanning is dangerous, so be mindful of what you're scanning. Be mindful of how you're doing it. If you scan a Modbus controller with some of these modern scanners, it could crash that. So be prepared for that. Have a plan to get back online. Tabletop, sit around and talk about, if we lose our ERP system, what do we do? It's gonna happen. I just told you guys, China is in everything. The day that they pull the trigger, if your manufacturing company stays online, the day that we break into whatever's gonna happen, you're gonna kill it. Just like COVID, you fucking killed it. Excuse me, you killed it.
I want to add to that. That's all right. So on August 20th, the Great Firewall in China tested shutting down 443. Now, if you shut down 443, let's say across the telcos, and Salt Typhoon got AT&T, Verizon, T-Mobile, and you're blocking, and you have the configurations, and you're blocking 443, what's going to happen to ZTE? Anybody?
What's gonna happen to what?
Your zero trust network architecture, all the stuff that everyone's brought up. You're gonna lose your VPNs, you're gonna lose HTTPS, you're gonna lose your management protocols that run on 443.
The humans are the most important factor, you guys. I can sit up here and talk about technology all day long, and I'm seeing every day what's becoming more important. Your ability as a human being to solve problems. I'm not a chemical engineer. I can get on the internet and I can make some chemical engineering stuff and do that. But your ability to solve a problem, your ability to react is still far greater than AI's. I totally believe that. And companies that take their best decision makers, their smartest employees, they elevate them, they give them more data, single pane of glass. I know we've all heard it, but one pane of glass, two panes of glass, whatever you need. Dude, we all know what a smartphone is, right? I still walk into factories where people pulling out flip phones. I actually have one in my bag I was gonna use, but you walk in these factories and there are people in the factories, it's the standard 80-20 rule, 20% of your people. Those 20%, we need to identify those people, we need to get them tools to solve their problems. That's what's gonna differentiate us. America ingenuity is far greater than any other country in the world. And although we might be lagging in AI, I'm not an expert to even say whether that's true or not, but American ingenuity is far greater. How do we secure it? Zero trust, multi-factor, least privilege, network segmentation, redundancy, secure your data pipelines, digital signatures, use certificates at both ends. We talked about these engineering laptops. I'm breaking my own rule, guys, but I'm not on the networks or anything here. But the engineering laptops are a great target, because if you get on an engineering laptop, you got all the tools right here to write all this stuff. So whenever you land, you got to use the tools of the land, right? So if you land on an industrial computer that only displays a web browser, you really don't got much to go with there. But if you land on the engineering worktop laptop, where you have the tools to program the PLCs, where you have the certificates, you have all the stuff you need. And as always, the easiest way to do any hack is to walk up to somebody and be like, username and password. You know, so those phone calls, these deep fakes. In the news recently, there was a banking company wired $30 million. They called the person to insure it, 30-minute phone call, deep fake. They didn't even know. They went and reviewed it. I wouldn't know, you know? So you can't trust what you're seeing. You can't trust anything on the phone. What can you trust? For now, you know, for now, I don't know whether you're a robot or not. Are we in the Matrix? I'm not sure, you know? But the human, that's what I'm saying. The human is more important. The human is becoming more important. What's happening here is the human is becoming more important. And a lot of people would think that was the other way, but I'm seeing it more and more. The value is in the human connection. The value is in the human ingenuity. Okay, redundant. Thank you guys. This is AI created. It took me like, dude, I wanted to make a safety video of me riding a robot like a bull. The robot looked like a bull. And I was like, so that's what I'm saying, is it doesn't always know what's going on. It took me forever to get these things right, you know, like, so the AI is, you can think all you want that it's going to take over the world, but the thing couldn't even figure out what I was trying to do. Thank you for attending. Like I said, I'm Anthony George with GCE. We help local manufacturers make these decisions. I love what I do. If any of you are into that kind of stuff, I'll talk all day long about it. I wish I had some sort of grand thing to say here, but have a good day.